Okay, so now we're going to find the inverse of the functions. We'll do it using algebra first, and to find the inverse, remember you switch the domain and the range. So we switch the x and the y. So this f of x means y. So I'm going to write, instead of y, I'm going to put x equals, and instead of x, I'm going to put a y. All right, I'm switching my x and my y. Okay, and now I'm going to solve for y. I'm going to get y by itself. So you always start with the furthest away number, right? And it's opposite of PEMDAS, so I'm going to add 6 to both sides. And I get x plus 6 equals y plus 2, that quantity squared. Or not squared, cubed. Okay? And then now I'm trying to get y by itself, right? I'm trying to solve for y, so I'm going to get rid of this 3 next, right? Go from the outside in. So this would be the inverse of y cubed would be the cubed root. So I'm going to take the cubed root of both sides. All right? And so that goes away, and I get y plus 2 equals the cubed root of x plus 6. All right? And then now I'm almost got y by itself. I just need to get rid of this plus 2, right? I've got a plus 2 here. So I'm going to subtract 2 from both sides. And so my final inverse would be the cubed root of x plus 6, all under the radical, minus 2 equals y. Okay? And then we're going to check to see if that is a function. And we can do that on the calculator. If I go to y equals, I can put in the original function. All right, so the original function is y equals, and I've got the quantity of x plus 2 to the third power, and the arrow over, minus 6. Okay? So there's my function, and then what I can do is I can draw that function if I go second program, all right, and it's draw, and then go down to number 8. See where it says, oops, go down one more. Number 8 is draw the inverse, so I'll hit enter. So draw the inverse, and I just need to tell it where that function, the inverse of what function, so that's alpha trace. Enter. So it's going to draw the inverse of the function stored at y1. All right, so there it is. That's my cubic function, and then there's the cubed root. All right. So remember, a cubic function goes like that, and then the cubic root goes like that. All right, and both of those are functions. They both pass the vertical line test. So my answer there would be yes. Okay, these are both, the inverse is a function. All right, looking at number 1, all right, I can put that in the calculator as well. That's going to be a quadratic, right, because it's to the second power. All right, so I know it's going to be quadratic. It's going to be a U shape, a parabola. So I'll go ahead and put that in. All right, so I have x squared plus 4. So x squared plus 4. All right, and then now I want to draw the inverse, so I'm going to second draw number 8. So draw the inverse, and then I'm going to do alpha trace to tell it where my function is, and I'll hit enter. So it's going to draw that parabola, and then the inverse is over here, right? It's a reflection across, here's the line y equals x, right? And the inverse is a reflection across that line. All these points go across. And so is that inverse the function? No, because the vertical line test crosses twice. So no, that is not a function. And then what's the equation of it? I can do that using my algebra. I can switch my x and y's, right? F of x means y. So I'm going to say x equals y squared plus 4. All right, I just switched the x and the y. And then now I get the y by itself. So I'm going to start by getting rid of the 4. All right, that's 0, so I get y squared equals x minus 4. And now I don't want y squared, I want just plain y. So I'm going to do the inverse, which is the square root, right? If you have y squared, the inverse is the square root. You always have to do the same thing to both sides. So I get y equals, and it would be the square root of x minus 4. The x minus 4, the whole thing is underneath the radical. Okay? And if you look at the picture, you can see that transformation-wise, the x squared plus 4, that was raised, right? It went up 4. That was the transformation. Okay? And then if you look at the equation here, where the x is under the radical with the minus 4, notice that went to the right 4. Right? That went over to the right 4. If it's underneath the radical, that's a horizontal, and it goes opposite what you think it would go. All right, excellent.